This is Module 6, Investigation 3, Graphing Rational Functions and Understanding Limits. Okay, so in this one, I'm going to do number 4. So using what you learn in investigation to fill the blanks below. Okay, so when x is, so we have to actually know what function we have to use. Okay, so function we use is right up here. Okay, all right, so there's a number 1, 2, 3, 4. So for the number 1, I have to use the f functions, which is x minus 3 over x plus 2. And then number 2, I have to use a g function, which is 3x squared over x minus 1 times x minus 3. For the number 3 function, I have to use the h functions, which is x squared plus 1 over x minus 2. For the k function, in number 4, I have to use the 5x over x squared minus 4. Okay, so for the when x equals infinity or negative infinity, which is the degree of the s function, the numerator function and denominator function is 1, 1, which is the same. So I have to use a coefficient, which is 1 and 1. Then horizontal s becomes y equal to 1. For the number 2 g functions, the degree is the 2. But also when you multiply x times x becomes a square too. So same degree, coefficients are 3 over 1. So it is a 3 and 3. Y equal to 3 is the horizontal asymptotes. For the number 3, the degree is a 2, but degree is a 1, which is numerator degree is higher than the denominator, which is there's no way you can get the asymptotes, okay? So you don't get horizontal asymptote. But equals infinity, but if you go to negative and then negative infinity, okay? And for the number 4, and then degree of the numerator is actually the 1, and degree of the denominator is 2, which is numerator degree is higher than the denominator, so it becomes a 0, okay? So y equal to 0 is horizontal asymptotes. So it depends on the degree, so you gotta check that out. All right, now in B, what I'm gonna do is I'm gonna graph the functions. So the B, number 1, I have to use the f function, so I'm going to rewrite again, which is x minus 3 over x plus 2. For the second function, I have graphing the g functions, which is 3x squared over x minus 1 times x minus 3. And for the number 3 functions, I use h functions, which is x squared plus 1 x minus 2. For the number 4, I'm using the k functions, which is 5x over x squared minus 4. Alright, so for the first functions, which is right here, right? So we have to find a few steps, okay? So vertical asymptotes is always set the denominator equal to 0, and so for x. So x minus 2, x equal to negative 2, which is, this is a vertical asymptotes. But we only find the horizontal asymptote from the A. So horizontal asymptote is y equal to 1. So y equal to 1. And then you just need to use a few more points. So a few more point means, actually the intercept too. So when x is, y is a 0, and then if you solve for x, x equal to 3. So 3, 0 is one of the x-intercept. Y-intercept means x is a 0, which is a negative 3 over 2, which is 1.5 negative, right? Yeah, so good thing is you already have a graph on this side of the 1, okay? And then I just need to use one more point, which is I always use a point next to the vertical asymptote. So this is a point I think I want to use, negative 3. So if you use a negative 3 and plug it in, I got 6, okay? So negative 3 is a 6. So 1, 2, 3, 4, 5, 6, about here. So your graph will be to this. Yeah. So that's a graph of the f functions. And for the g functions, okay. So for that is vertical asymptote, always set denominator equal to 0. So which is x minus 1 times x minus 3 set equal to 0. And then you get the x equal to 1 and x equal to 3. So there are two vertical asymptotes. X equal to 1 and x equal to 3. And then you got the x-intercept, which is y is a 0. So But it's a 0, 0 this time, okay? Which is the same answer, minus F2. It's a 0, 0. Alright, so it's a 0, 0 here. But we have a horizontal asymptote, right? Which is, I got y equal to 3. But we might get a little bigger number here, so I'm going to label as, on the y-axis as a, I'm going to say this is a 2, 4, 6, 8, 10, 12, 14, 16. Other sides, I got negative 2, negative 4, negative 6, negative 8, negative 10, negative 12, okay? Let's just put it this way. All right, so as a point, so that's not enough, right? So we have a horizontal asymptote is y equal to 3. So about here. Yeah, this is a 3. So let's see what happened here. So, and then I'm going to make a table. Of course, it's a plugin, okay? So I'm using the 4, which give us a 16. And if I use a 2, negative 12. And if I use a 1/2, I got 0.6. Okay, so I want to just see. So 4. So 1, 2, 3, 4, 16. Way up here, isn't it? Way up here, right? So you have a graph like this on this side. And then 2 is a negative 12. So 2 is right here. All right, so this one here. Do you see? Okay. And then if you use other stuff, so you graph like this. And then if I use the 1/2, which is right here, but the good thing is you already have a point here, but I want to see actually what happened to the 1/2. So 1/2 is about here, right? But 1/2 give us the 0.6. So 0.6 is up here. But actually, this time is actually the graph crossing it. The horizontal axis goes this way. For the h functions, you're going to have a vertical asymptote. It's going to be x equal to 2. Horizontal asymptote, there's none. But this time we have a slant asymptote. So how do you find it? We divide it. So x squared plus 1 divided by x minus 2. X squared divided by x is x. So x squared minus 2x. Subtract. You got 2x plus 1. 2x divided by x is a plus 2. So you got 2x minus 4. But we don't really need the remainder. But this is makes a slant asymptote. So y equal to x plus 2. So y equal to 2 line first. And then y equal to x plus 2 is just start with minus 2. And then the slope is 1, 1. So we got this kind of graph. Here too. And then intercepts. But there's no x-intercept this time. X-intercept is none. But y-intercept, there is 0 and negative 1 over 2. Which is 0 and negative 1 over 2 is right here. And then if we have a point at x equal to 3, it's a table, right? And then 3, if you plug in, you get 10. So 3 is a 10 up here somewhere. So you have a graph up here. And actually, you're having a graph up down here too. This kind of graph you'll see. Then k functions, which is vertical asymptotes, which is x equal to plus minus 2 because the denominator is x squared minus 4, z equal to 0. Horizontal asymptote, y equal to 0. So you have a 2 vertical. I shouldn't do this, okay. It should be connected, okay. Sorry about that. And then the horizontal asymptote is right here. So, and then if you use the x-intercept, y-intercept come out the same, which is a 0, 0. So it's crossing the horizontal asymptote this time too. And then if you use a table, for this one, x is a 1, y is a negative 5/3. X is a negative 1, you got positive 5/3. 3 is a 3, and then negative 3 is a negative 3. So 3 is 1, 2, 3 right here. So you got the graph of this. And -3, which is 1, 2, 3 right here. So 1, 2, 3 is a -3, -2, -3, right? Yeah, so graph is going to be this. And then if you use 1 is going to be the negative, right? About here, right? And then negative is a positive, right? So your graph is going to be something. Yes, I connected. Yeah, this way. Okay. All right. I'm sorry, the plane was split. Okay. All right, that'll be all for the 6.13. Thank you for listening.